How's it going, everybody? In this video, we're going to take a look at our next EIGRP topic, which is EIGRP Authentication. And there's a couple different variations that we can look at, and we're going to take a look at those as we go along. We'll take a look at it on iOS first, then we'll take a look at it on iOS XR, and then we'll take a look at some more advanced options. So if you've done EIGRP so far, we've covered some basics, getting adjacencies up and running, talked a little bit about how EIGRP works. Now we're going to dive into how do you authenticate a peering? It's actually a really big deal because especially if you work in a really large environment, or you are, if you want to just increase the security in your environment in today's networks, almost every environment that I've ever worked in, authentication's been there. Whether I've added it because of request, I've mentioned it because I think it's worth it, or because the customer, we want to add another layer of protection to the environment beyond what's already there. So when we talk about authentication, it's not very complicated, honestly, what's going on. There is one type of authentication that EIGRP supports, which is type 2 authentication, and that is going to be with a hashed password, meaning either MD5 or SHA. So those are going to be you take the password and you throw it you put the password through an MD5 algorithm, or you put it through a SHA algorithm to get the desired effect. So let's go ahead and talk a little bit about how this works and go through the details that we need to understand. So let me do just a touch of whiteboarding. And did my thingamabobber go away? Let me go ahead and just exit. Yes. And go ahead and pull up there we go. So how does authentication work? Well, the way that it works in a nutshell is if I have a router, let me make that a little bit bigger so you guys can see what's going on. Let's go to red and make this a little bit bigger so you guys can see it. Let's go to thin. So if I have a router, R1, and then I have R2 sitting over here. And there is a link between these two, and EIGRP is enabled on this circuit between the two devices. When hellos are being sent back and forth, or a routing protocol update is sent because more routes have been advertised, whatever the capability or whatever the process is, the EIGRP portion of the header. So I'm going to draw a pretty remedial packet here. If this is your EIGRP packet, here is where the authentication, not specifically this portion of the packet, but this is the EIGRP packet itself will be authenticated. Again, there's two ways you can do this. You can do it with MD5 or SHA. Now, SHA is going to be a little bit better of authentication because one, it takes more bits to do, and it provides you a little bit more flexibility. Now, if you were just to go back and forth and set up EIGRP to do the authentication, you could do it back and forth this way, like we see it right here, or you can do what they call key chain rotation. This is a little bit more of an advanced concept, but the idea is you have a key chain, and we'll call this key chain. Then you're going to have key 1, and then underneath here you're going to have the key string. Now the key string will be some sort of password, like Cisco, for example. And what you'll do is here you'll define the keychain, and you'll use, if you want to enable SHA, you'll use the cryptographic algorithm is the command that you'll use underneath the keychain configuration. And then you give it a start time and an end time, and basically validity dates. And then key 2 will be the next one. And then you give key 2, key string, cryptographic algorithm, and then validity dates, which basically says the validity dates. Let's say, for example, we're almost in 2021, but we're at the end of 2020 right now, right? So if I say it is the time of this recording, it is 10/28/2020, and it is basically 10 o'clock at night. So 10 p.m. Now, if I want to set up authentication with another device, their date and their calendar information as well as their clock need to match this, because if I try to do authentication between two different devices back and forth, this information right here is going to be sent back and forth. And if this stuff does not line up, then the adjacency will fail. So how do you go about doing this? Well, you can set the clock time, or you have NTP deployed in order to synchronize the time across all of your devices. And then what you end up doing is you set your keychain up. So for example, if you wanted the keychain, if you want to go from key 1 to key 2, you can put the validity dates for key 1 to end. So we'll say the start is 10/28/2020 at, let's say, 9 p.m., for example. The end will be 10/29/2020 at, let's say, 12 a.m., so basically midnight. Then what I could do is, this is key 1. Key 2, the start time will be at 10/28/2020 at, let's say, 11:30 p.m. And then the end time for this guy will be whatever, let's say forever, for example, just to make it easier to understand. Now what's going to end up happening is the key 1 will be valid from 9 o'clock at night on 10/28/2020 until midnight of 10/29/2020, and as soon as this time is reached, this key will be invalid. Now this key down here, start time is 21:30. Okay, so before this time ends, but after this time starts. So basically key 1 and key 2 at 9:30 at night will both be valid here, and this one will be valid as well. Now what will end up happening is you'll have key rotation set up so at a certain point in time you'll migrate from key 1 to key 2. When key 2 goes active, key 1 should also be active at the same time so that you can transition from one key to the next. And what you can do is once this key starts, once key 2 has started, you can migrate from key 1 to key 2, and then when key 1 becomes invalid because of the date and time, it has now reached the expired time, key 2 should still be active and beginning its life cycle so that you can transfer from key 1 to key 2 and then move forward from there. That's basically what ends up happening. It's key rotation. It's not a complicated topic to understand, but it's really lining the calendar up and the clock to synchronize so that when you go from key 1 to key 2, that the transition between one key and the next does the transition the way you need it to. And that's the kind of the tricky part to this whole design. So that's basically how that comes into play. Pretty cool stuff when you break it down to brass tacks. So let's go ahead and take a look at this on the command line and go through these couple of examples. It's not very difficult. You just need to understand what's happening. So let's go ahead and scoot up here, and we're going to go pull up Secure CRT. And I'm going to do this between iOS 6 and iOS 5. So what I'm going to do is I'm actually going to take down, in a previous video I had some other stuff going on. So what I'm going to do is on iOS 6, I am going to go to global config, and I'm going to type in no router EIGRP1, and that'll take EIGRP down for me, and I won't have to worry about anything there. Now I have EIGRP 100. Now I'm using EIGRP 100 through this entire environment. What I'm going to do is I'm going to quickly get everything back up and running, because right now if we were to do show IP route, EIGRP is not really running anywhere. So we're going to type in router EIGRP 100. We'll type in network of 100.0.0.0, 0.0.0.25, 255.255.255. If I do show IP interface brief, we should be in pretty good shape with that setup. So I'm going to do show run section EIGRP. And give that a second or two to pull up. There we go. Basically, we're saying just enable EIGRP, and no auto summary. So we should be able to take this command like so and go over to router 6, or I'm sorry, router 5. Do show run section EIGRP and make sure that there's nothing running here. Go ahead and paste that command in there, and then we'll go over to 4, do the same thing, and paste that in like so, and then iOS 1, same thing, just to get everything up and running. There we go. So now we have that all squared away. We do a show IP route now. We should have a bunch of EIGRP routes being learned, which we do, which is what we want to see. Now, what I can go do now is I can go start focusing on getting the authentication piece going. So one of the things that I'm going to do real quick is I'm going to do this between 6 and 5, and I'm actually going to capture on gig 1. I'm going to right click here, go to capture, and on gig 1. So okay, so the problem I have right now is the SSL thumbprint for this connection for SSH is not working. So let me show you how to fix this. So if you ever go to EBNG and you want to capture on a particular interface and you don't have the right information, let's go to 10.255.1.30 and then connect in via SSH. We should get this little guy right here. If you get this, which says that the RSA2 key fingerprint is not trusted, we can close out right away because all we need is that. I'm going to right click here, go to capture, gig 1, and then we should get a little pop-up like this. If you get this, if you get anything other than this, that's a bad thing. So I'm going to come in here and do EIGRP. So we're going to capture just on that. I'm going to bring this down just a little bit so everybody can see what's going on, and bring this down just a little bit more. And I'm going to put this up at the top right here. And let me go ahead and minimize this so that we have everything we can see. Let me keep this out of, let me show it to you on screen, but I'm also going to configure between 5 and 6. So between 5 and 6, on 6, I am going to go just do basic authentication. I'm going to type in interface gig 0/1, IP EIGRP, IP authentication will be mode, will be EIGRP for Autonomous System 100, and it's going to be an MD5 digest. Hit the enter key. Now we're going to go back here. Now that automatically takes down the adjacency, right? We're going to come back to authentication keychain. In this particular case, we're going to say for EIGRP, we're going to say AS number is 100, and the keychain name is going to be EIGRP. Something very, very simple for us to work. Nothing, no additional steps needed there. I'm going to go and create keychain EIGRP. I'm going to say key 1, and underneath here, I'm going to basically say that the key string is Cisco. Something very, very simple. Very, very easy to work with, right? Now what I'm going to go do next is I'm going to basically say we do show key chain. You'll see that it's always valid, no matter when, valid now. So now if I go to router 5 and it says authentication failure. So if we were to debug this, debug EIGRP packet hello, you would see that the information going back and forward, we should get a notification that the authentication is incorrect. Let's see if we'll get that. I don't think, maybe it won't. Do it on debug all real quick. What I'm going to do is I'm going to go to global config, and on router 6, I'm going to come down here and do a debug IP EIGRP, and I'll say packet, or debug EIGRP, and then packet, and I'm looking for hello, and which will have the EIGRP authentication enabled. So I'm going to type in keychain EIGRP key 1. Key string is going to be Cisco. And then underneath interface gig 0/1, excuse me, we'll type in IP EIGRP or authentication. For the mode will be EIGRP 100 for MD5, and then we'll do keychain EIGRP for the autonomous system 1 of 100, and the name of the keychain is EIGRP. Okay, so now what should end up happening is we should get some information going back and forth that says that it's working. And there we go. So we have that going with us, and we're in good shape. So I'm going to undebug all. So what we see when we get that information back and forth, let me go ahead and look at this. We can see the hello going from here to here. If we bring this down just a touch, you'll see that we are doing authentication right here. Authentication MD5. We can see that we're using type 2 authentication. Key ID is 1, but there's no actual, the key itself is protected with this inside of this digest. So that's how we know we're doing that. So let's go take a look at the next one, which is going to be SHA authentication. So let's go ahead and do that between 4 and 5. So we'll add this up. We'll add a little bit more complexity to the environment. So between 4 and 5, I'm going to go type in key, and chain is going to be, we'll say SHA. And underneath here, we're going to do key 1. And then underneath the key string, we'll type in the key string itself is going to be Cisco. But the cryptographic algorithm that's going to be used, and we have the option of changing the value. So you can go up to 512. I'm going to choose HMAC SHA-1. And I'm going to paste that in. And then I'm going to go and configure the same thing over on router 4. But I'm going to type in interface gig 0/0, IP authentication for EIGRP for the mode will be EIGRP 100, and actually we don't have to do the mode there. We just have to do the keychain for EIGRP 100, and the keychain name will be SHA. Okay. Now let's take that and take down that adjacency. If I go over to router 4 and I go to keychain SHA, then key 1, and then the key itself will be Cisco. The cryptographic algorithm will be HMAC SHA-1. And then I'm going to go ahead and come to interface gig 0/1. We'll type in IP authentication for the keychain will be EIGRP for autonomous system 100 with the word of SHA as the keychain, and hit the enter key. Okay, so now if I do show IP EIGRP neighbors, I should have an adjacency with router 5, which I do. If I show IP EIGRP interfaces for gig 0/1, and we look at the, we might have to go to detail for interface or gig 0/1, we'll see that authentication mode is not set. Is that, let me just make sure that interface gig 0/1 IP authentication mode will be EIGRP 100 MD5. We probably have to use this with named mode. So let's go convert this to named mode. So we'll do no router EIGRP 100. We'll take that down on this guy. And we'll type in router EIGRP, we'll say named mode. And underneath here we'll type in address family, IPv4, autonomous system 100. And underneath here we'll type in network of 10.0.0.100.0.0.0, and we'll specify basically all 255s, and that will form EIGRP adjacencies, which is what we want to see. And we're going to go to router 5, do the same thing. We'll type in no router EIGRP 100, router EIGRP named mode, and then we'll go underneath the address family IPv4 autonomous system 100, network of 100, and do that, and that should form adjacencies, and we'll be in really good shape there. And we'll have to adjust the configuration on the interface facing router 6 because he'll have a problem with this. Because if we do show IP EIGRP interface, we're going to be enabled for everything, but we're only going to have adjacencies on gig 0 because of the authentication with with router 6. So what I do now is I don't actually configure anything outside of I can configure a keychain. What I get to do now is type in AF interface on router 5 of G0/0, and underneath here I specify authentication, and then the mode will be HMAC SHA-256, and then I can specify the password. So in this case here it's Cisco. Makes it very, very easy to work with in terms of the operations. And then I get to go, now it's down, the authentication has been enabled. So if I go back over to router 4 and I go to, it says auth failure, which is very, very intuitive. If we go underneath AF interface or gig 0/1, we'll type in authentication will be mode HMAC SHA-256 with Cisco as the password, and hit the enter key. So after a couple of seconds we should form an adjacency. There it goes. So authentication is working the way that it's expected to. So these are the type of things that would definitely come in handy. So do show IP EIGRP detail or interfaces detail for gig 0/1. We can see that authentication mode is set here with HMAC SHA-256 with keychain not being set yet. We haven't flipped over yet to the keychain rotation yet. So let's go ahead and take a look at our next step. Let me go ahead and minimize Wireshark if they don't need that at the moment. So that's going to be the next step for us to go through, is do the rotation. So if we want to enable a keychain, we can. We can type in keychain, and we have to make sure that the times match up. So what I'll do is I will type in keychain and we'll say SHA, and underneath here we'll type in key 1, and we'll specify the key string will be Cisco, something very, very simple to work with. And then we'll have to do the accept lifetime and send lifetime. Accept means you're going to accept a key as long as it's within this time span, and the send is you will only send a key if the time is within inside of these boundaries. So we're going to type in the accept lifetime is going to be, we can specify a time if we want, so we do show clock. It is 11 o'clock at night. It's actually a little ahead, but that's fine. It'll work. And what we're going to do is the accept lifetime will be the low. Well, I'm going to go ahead and specify that it is 22:30 on today's day, which is October 28th, 2020, and with a time to stop, or you can put even a duration if you wanted to. And we will put in, we'll put in 23:00:00 on October 28th, 2020. Something very simple like that. So do show run section key. So that is going to be our accept lifetime. So it's going to basically give us a half an hour. So if we come over here and we adjust this, we're going to say the send lifetime, and then we're going to adjust this from the same value. That's for key 1, right? So now we do show run section key. we should come out with the exact same value. So we're going to send and receive the same time frame, right? So we have a little bit of wiggle room to work with. If we do show clock, our clock is, it's actually the key. I need to bump that up a little bit. I need to adjust those times to make it 23:30, because right now we're just after 11 o'clock. So if I go and adjust this one to be 23, we'll say 30, and then adjust this one, because this is now the accept lifetime. If I make this one to be 30 as well, and do show key chain, we can see that its key 1 is good to go, and it's available, it's valid for about a half an hour. So if we do show run section key, make sure that we're adjusting the appropriate values. So I'm going to adjust this one here, and we're going to make this 30 as well, just so we have time to do our thing. Do show key chain. Alright, now everything's looking good. Everything is valid now. What I'm going to do is I'm going to exit out and type in key 2. The key string will be Cisco with a 0, so a different password. And then I'm going to adjust these values. So I will set the accept lifetime to be 23:30. So I'm going to actually adjust this one to be 2300 on this date. So we'll 0 here, and with a end time of, and we'll say 23:30, which is what we need it to be. And then I'm going to set a send lifetime here. I'm going to adjust this one to be 2300. Oops. And 23:30. Okay, so now do show run section key. Just gotta make sure that the times overlap with each other. So key 1 will be valid from basically 10:30 to 11:30. In the send will be 10:30 to 11:30, and then key 2, which will be key string 0, Cisco with a 0, will be valid from 23:30 to 23:30 as well. The send and accept lifetime. After that, it'll die. So now what I get to go do is take this exact same configuration over to router 5. So let's copy and paste this out and take this over to router 5. I'm going to go ahead and get out of this, and I'm going to paste this in like so, exit out, and then I'm going to go to router EIGRP named mode. Underneath AF interface or address family IPv4 autonomous system 100, AF interface is going to be gig 0/0, and then underneath here I get to type in authentication, and then the key chain will be SHA, and that's all I have to type in. So I'm going to do that, and then same thing on router 4, key chain changed, and I'm going to go to router EIGRP named mode, address family IPv4 autonomous system 100, AF interface is going to be gig 01, and then the authentication will be keychain. The name of the keychain will be SHA, and hit the enter key. There it goes. So now if we look at this configuration, we do a show keychain, we can see that they're both valid, right? They're sending and receiving now. Everything's looking pretty good. Now if I was to take this time, and if we were to look at show IP EIGRP interfaces detail for gig 0/1, we can see that we are using keychain is SHA, and if we were to do a debug on this, on router 5, let's jump out here and do a debug IP EIGRP, sorry, debug EIGRP packets hello. We should see key 2 being exchanged as soon as it goes through. And we are receive packet with that information in it. Let me do a quick Wireshark capture on that one. So let's capture on gig 4, on gig 01. I'm sorry, on iOS 4 on gig 01. And we'll look at EIGRP, and we will look at this communication right here. And if we look down here through the configuration, the authentication SHA-256, we are using key ID 1 currently. Okay, so what I'm going to go do, since this is happening in real time, I'm going to go adjust that real quick. I am going to go back to router 4, and I'm going to do a show key chain. We can see that both keys are actually valid. I am going to make key 1 less valid. I'm going to adjust the time, so we do a show clock. I'm going to adjust that down to where this one here is now 2300. Show run section key. Go to global config. Underneath here, I'm going to go key 1, and the end time, I am going to adjust this to be 2300. And same with this one. Make this 2300. So now key chain 2 should be used. Or I'm sorry, key ID should be, ID 2 should be being used. Do show key chain. Now this is the only one that's valid. And if we look through here, oops, the value should change. Let's make sure 5 is squared away. Key not, so it says right here, packet key ID 2 not, key not live yet. Okay, so if I undebug all for the moment, just so we can take a second here and show run section key, make sure that it's actually valid. And so we've got the key config show key chain. It says this one is valid, this one is not yet. So we need to make this one valid. So this one technically hasn't become valid yet because we do a show clock. This one is saying 2246. So what I'm going to do is I'm going to say clock set to be 23 colon, what is the other one set to? Let me just make sure, do show clock. We're saying 2308. I'll make this one 2308 as well. On October 28th, 2020. Okay, so now the clock has been set. It's been updated. And we can see the adjacency is good. If we do a show clock, show keychain, they're both valid now. And if we look back at this value right here, we can still see that this one here is being used. It's still using key ID 1, right? And that's what we want to, we have to adjust this value. So what we have to go to here is do show run section key. Let's see if this one's updated. It's still using key 1. So what I have to go do again is on this one here is adjust this timer to be 2300. Let's just do 2305. But technically that's the only one I really need to set. And then I'll take this one here, send lifetime for key ID 1, and I'll make this one 2305. Do show key chain. We can see this one is valid now. Look at this one here, key 2. This one's using key 2 now, which is what we want. The key ID has been updated. We're still using SHA authentication. I'm just showing you that by adjusting the values of the key or the clock. And I'm doing that just the instance of time. I don't feel like waiting around for 15 or 20 minutes. I can just simply change the configuration around a little bit to change the send and receive lifetimes to when they're valid and invalid. And now we can see that we are valid now for key ID 2, so the second key. Think of it like having a key ring, a physical key ring, and you have your house key, your garage key, your car key, your office keys, whatever else. Each one does a separate thing. In this case here, the key is just a digest that's being exchanged between the devices. So this is one of those more advanced concepts, and it can be a little tricky to follow. I get that, but it's by making them valid and invalid and changing the attributes around a little bit. It's not terribly complicated to follow. Customers do use this. I ran into this more times than I thought I would, but that's the beauty of playing around with it so you know what's going on. So pretty straightforward stuff in terms of the operations. So if you have any questions, please let me know in the comment section below. And until next time, guys, take it easy.